Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to find and apply the dot product. So the instructions are as follows. We're to find the dot product of the given vectors. Okay? Alright, so now let's say we have vector A as 3, 9, and vector B is 1, 4. So we are asked to find the dot product. So what is the dot product of vector A and B? Before we start this, let's go ahead and write down what the formula for computing the dot product is. Okay, so the formula is as follows. So let's assume that A is x1, y1, and vector B, the second vector is x2, y2. Then the dot product of the two vectors, A dotted with B, is a scalar quantity given by the product of the x's, x1 times x2, plus the product of the y's, y1 times y2. So you want to recollect the fact that anytime you multiply vectors, your final result is a scalar quantity. It's no longer a vector. Okay? That's why the answer is not in component form. Okay, so let's go ahead and apply this formula here. We can clearly see what x1 and y1 are and x2 and y2. Okay, so the dot product of A and B is simply the product of the x's. So 3 times 1 is the product of the x components of both vectors, plus the product of the y components, so 9 times 4. Alright, so let's go ahead and multiply these following the order of operations. Multiply first before we add. 3 times 1 is 3, 9 times 4 is 36. So what is the sum of 36 and 3? 36 plus 3 is 9, so it's 39. So 39 is the dot product of vectors A and B, which is clearly a scalar quantity. Alright, what if we were given two vectors in linear combination form? Okay, so let's see, vector A is given by 4i minus j, and vector B is given by 2i plus 4j. So the question is, what is the dot product of vector A and vector B? Okay, so what is it going to be? It's going to be exactly the same process. If you have, let's write down the formula for the dot product of vectors in a linear combination form. So if you have a vector A, given as x1i plus y1j, and vector B is a linear combination form, also x2i plus y2j, you can easily assume what the dot product is going to be. Is going to be exactly the same as we did in the previous example. The product of the x's, the x component of the two vectors, added with the product of the y components of the two vectors, and that will give you the dot product. Okay, so let's go ahead and find what the dot product is here. If we dot A and B, we multiply the x component, also known as the horizontal component of both vectors, 4 times 2, and then we add that to the y components. The coefficient of j here is clearly negative 1, so you have to be careful with that. So we have negative 1 times 4. Okay, so when we simplify this arithmetic expression, the scalar numeral will be the dot product. Okay, so 4 times 2 is 8. And then we have negative 1 times 4 is negative 4 times positive. It becomes negative 4. 8 plus 4 is 4. That shows us that the dot product of A and B, in this case, is simply the scalar quantity 4. Alright, for the next example, we're going to be taking a look at one of the applications of the dot product, and that is in finding the angle between two vectors. Okay, so the instructions for the next example are for us to find the angle theta between the given vectors. Okay, so for number 3, let's say we have vector u as negative 24, 3, and vector v is negative 8, comma 1. Now we want to find the angle theta between vector u and v. So what is that? So let's take a look at what the formula for finding the angle between two vectors is. Okay, so the formula is theta equals the inverse cosine of the dot product of the two vectors divided by the magnitude of the two vectors. Okay, so that's basically how you find the angle between two vectors. So as you can see, this formula is pretty complex. It has multiple components to it. In order to be able to find the angle between two vectors, we have to find the dot product, and we have to find the product of the magnitude of the individual vectors. So let's write this down. We need to find 1, the dot product, u dot v, and 2, we need to find the product of the magnitude of the two vectors, and then we'll plug it into this formula and we're good to go. So let's start with the first part. Let's find the dot product. So let's find u dotted with v. Okay? Alright, so let's write down the formula again for the dot product. So if we have vector u is x1, y1, and vector v is x2, y2, then the dot product is simply the product of the x components the product of the x components added to the product of the y components of both vectors. Alrighty, so let's go ahead and use that to find what u dot v is. So u dotted with v is going to be the product of the x components of the vectors, the horizontal component, negative 24 times negative 8, added to the product of the y components of the vectors 3 times 1. Okay, if we work that out, negative 24 times 8 is positive 192, plus 3 times 1 is 3. Add this together, we get the dot product of 195. Okay, so this is an intermediate solution that is needed to find a bigger result, namely the angle between the two vectors. Okay, now let's go ahead and do the second part, part 2. Now we need to find the product of the magnitude of both vectors. Okay? Alright, so let's go ahead and write down what the formula is for that. So let's say we have vector u as x1, y1, and vector v is x2, y2. The product of the magnitude of both vectors just simply involves finding the magnitude of each individual vector and then multiplying the result. So the magnitude of vector u is simply the sum of the squares of the x and y components. So it's going to be the square root of the sum of the square of x1 and y1 square. Okay, so this will give me the magnitude of u. You can easily determine what will give us the magnitude of v, right? You simply find the sum of the square of the components. So it's going to be the square root of the sum of x2 square plus y2 square. So that will give us the magnitude of vector v. Okay, let's go ahead and apply this formula to this problem. We are going to have the magnitude of vector u times the magnitude of vector v as going to be the square root of negative 24 square plus 3 square. That's the square root of the sum of the squares of the components for vector u, which is right here. Vector u is negative 24, 3. And then for the v component, the magnitude of v, vector v, we're going to find the square root of the sum of negative 8 square plus 1 square. Okay? Just simply applying this formula to vectors u and v given earlier. Okay, let's go ahead and simplify. Square root 24 square is 576 positive plus 9. And we're going to multiply that. 8 squared is 64 plus 1. That gives us the square root of 585 times the square root of 65. Okay? So when we do that, we're going to end up with the product. Let's go ahead and calculate what that product is. So we're looking at the square root of 585 times the square root of 65. And we get 195. Okay? So the intermediate product, if we do 5, let me just show you the steps. 585 times 65. That's 38,025. And when we take the square root of that, that will give us a nice, perfect, gives us an integer. Okay, that's great. Alright, so we've now found the two components that we need. Now we are now in a position to compute the angle. Okay, so now theta is going to be the inverse cosine of the dot product, which is 195, divided by the product of the magnitudes, which is also 195. And that's going to give us the arc cosine of 1. Okay? So let's figure this out using our unit circle. So what is the inverse cosine of 1? So I want to write it using a combination of x and y coordinates on the unit circle. So I can easily write this as of 1. So we ask ourselves in the unit circle, we know that on the unit circle the x coordinate is basically given by cosine. of the angle of an angle. Okay, so x is basically cosine of the angle, and then that basically tells us that theta is going to be the inverse cosine of the x coordinate. So 1 is basically an x coordinate, so we want to ask ourselves on the unit circle, what angular value um, is a scenario where the x coordinate is positive 1. And if you sketch your unit circle and you graph positive 1 on your unit circle, you're easily going to see what the answer is. So let's sketch that real quick. So there goes my unit circle. When you graph positive 1 on the x, you have this point right here, which is 1, 0, and the angle is 0 degrees. Okay, you can also use the graph of the cosine function to figure this out. So let's look at that also. So if you draw your cosine function, remember it looks like a cup. So you have your cosine function, looking something like this. That's one complete period from 0 to 2 pi. Okay, so that's pi. And you're asking yourself, where is cosine? When does cosine have an output value of 1? And we can clearly see that it's at 0 and also 2 pi, but we're just going to take 0. Okay, so what does that tell us? It tells us that the inverse cosine of 1 is 0. And that, ladies and gentlemen, is the angle between vectors u and vector v. It basically tells us that the two vectors are parallel. Alright, so let's go ahead and write down a statement real quick to sum up all the work we have been doing. The angle theta between vector u and vector v is 0 degrees. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study of vectors, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to support you. Do not forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.